Okay, boys and girls, welcome to the lab. Says we're live. I suspect we're live. We are going to be taking measurements today on the driver circuit again. Oh, and I'm listening to myself talk. Turn that off. At least I know it's working. Oh, wow. Okay. Alright, so I'm cold. I got the heater on in here. Hopefully it's working. So I'm going to reconfigure scope leads. I'm going to try to measure only the pulsing system again. I'll leave everything connected though. Oh. Okay. I'm just gonna go in order. Scare them out. Hey! You know what I got to say, Jimmy? Listen to this. Hey! How you like it? Now that should scare you. Anyway. I need to put the colors on these other probes. Guess I could do that real quick. Cracked it. Okay, so I'm gonna go ahead and use colors I used on those. We got green and blue. Teleporter for temperature. A teleporter for temperature? What? You mean like some way to transfer heat? Alright, so we got green and blue now, so we'll be able to tell what we're looking at. So this one's blue. This one's green. Alright, so today we're going to take measurements of the driver circuit. And that's all I'm really interested in for the moment. I'm going to switch out a TIP120. I've got a couple different versions of the TIP. I think these are other versions. Yeah, these are from a different company. That's a generic, really generic one, and this is a better version. So we will do that. Oh, and I was going to change the, not yet, but I'm going to change the cores. That's a tedious work. I want to take the gap out of there. Okay, so channel 1. Alright, I'm going to measure the base of all of these. So let's start out with the last one first. So green first. And that's going to go to the base. No, actually, I want to go across the coil with this guy. I need to make sure I get these connected right too. Last time I had them reversed, which made it very difficult to measure. Okay, so the last one is going to be the actual output of the TIP120. So what I'm seeing across the coil, basically. And then the next one, channel 3 is the base of the TIP120. Channel 2, which is blue, so it's channel 1. Channel 4 is green, 3 is pink or purple. Channel 2 is blue, and channel 1 is yellow. So then we're going to measure the base of that next one, and then we're going to measure the base of the next one. Okay, we should be measuring something interesting here, so, well, not interesting, but I'm just going to turn it on, and I'm going to do alright, so channel 1 is the first stage. Just put it up here. Channel 2 is the next stage, so we will put it in the middle. The pink one. Okay. Wow, where's 2 at? 2's on... Yeah, the base. It's really offset a lot. It's kind of strange. Okay. So what I really want to do, I'm going to set the triggering channel 1. Take off these cursors. Huh. Never seen this place. USA inventory, let's see. There's a 1 inch by 2 inch by 1/8. Let's see, let's go to 3/8, no, 5/8 diameter. 3/4 diameter, okay. 3/4 diameter. Well, they don't have the ones I usually get, but those are cheaper, the shorter ones there. Yeah, I'm testing some VIC stuff. Okay, here's what I want to know. I just want to do this real fast. Whoa. I just want to know okay, so it is just the tip. So the TIP 120 is doing all the work. Huh. Interesting. That is quite interesting. It's still not truly 50% duty cycle, but the TIP 120 is definitely screwing us up here. So, okay, so let's turn that off. And let's switch out this tip for a different tip. This is a cheap tip, I think, in my opinion. Let's put a good one in there. A more expensive one, I guess. So this is a... I don't know if you can read that, but TIP 120. Let's put it in there. Just a different manufacturer. Turn this back on. Oh, now I can go even higher. So now I'm all the way up to 30. But even at 10 kilohertz, it is just so far off. So let's take a well, you know what? I don't think a measure will actually shows it in period. And it won't. I want to change. I don't want to have to do this manually. Apparently I am going to have to do it manually. It is not really doing what I want. Danny, no, it's very special to use these particular components because we're trying to figure out how the original circuit functioned, and it definitely functioned differently. Alright, so I'm not going to move anything. I'm just going to turn the power off. I'm going to pull this TIP 120 and put in the old one I had. Turn this back on. And you can see we changed by that much. I wonder if I can read a resistance value across this tip. Alright, so from the base to whichever one goes to the ground, I cannot measure. Oh, I'm sorry. The base to whatever goes to the ground, this one is almost 8K. And this other one is 9.38K, if these are good measurements. And then the output to the base is 3.19 meg on that one. And almost 3 on that one, 2.92. So this value changes characteristics. So I wonder what, yeah, that's what I want to look up, Danny, actually. And this is even a different version, right? So but I want to see what the it's power watts. I want to see if there's a frequency curve. Here we go. That's a thermal response. Frequency in kilohertz. Small signal current gain. I mean, these frequency curves go way past 100 kilohertz. This particular one that you showed me, between the base and the emitter, we can measure the resistance. So, for fun, let's see if we're actually measuring that. So I gotta find this brand. TIP120 CCORH W. I have no idea if those numbers will help me, but because each manufacturer is different. So I wonder we can see what this is, a MRC ST component, 1608. Alright, here's a so those are the generic ones. That's got an F. So Friendchilds or whatever their name is. And the other one has an ST. So here is one from Fairchild. Oh, come on. Alright, so for Mauser, this is a Fairchild. Okay. So this one's supposed to have no, it doesn't have a, oh yeah it does. Okay, 8K and a 0.12K. So this one's supposed to have an 8K. It's measuring 7.83, which there could be losses in there. And the other one is an ST component. So I forgot what the ST company is. Find out real soon because I forgot. I still don't know. Okay, and this one is an NPN R2 is 70 and R1 is 7. I'm measuring 10K, so there's this method of measuring isn't really very good. But we know one is 7.7 in a total resistance value, and the other one, so 7.7, and the other one is 8.12. So there's your difference. Now, Matt made a curve, and he says the lower the resistance, the higher the curve. The lower the resistance, the higher the curve. The lower the resistance. So the ST1, the lower the resistance. The ST1 has a lower resistance, and it indeed does have a higher curve. So this one is holding a better frequency. And then let's see if it matches his numbers. He put a 5K in there, it went up to 23. Well, I can get this one go up to like 30. Technically. So
there's like 30 right there, and I'm still getting an okay peak through there. Oh, if I get a negative peak. Okay. Well, then I guess I'll just stick with the ST version. Write some notes. ST version. ST version has a Hello, Kevin. Alright, so... Okay, so... R1 and R2. Plus... R2 of, okay, ST is oh, maybe it's a PNP or an NPN, I don't even know. TIP120. It's a NPN. Okay. It's an NPN. So it's got 7.07K. 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 Its top cutoff is, that's what I'm using, its maximum frequency. We'll call that 35. Alright, and then this one is 8.120. Okay, that's this one, 8 plus 0.12K, so that's 8.12K. 8.12K, its top cutoff is, let's find out. call that 22. 22-ish. Okay. Let's just go ahead and put the values. This one's 7K. This one is what would that be? 0.007K. 70. That would be 0.07K. Okay, and then our one on this one. This is the ST. Oh, I did those backwards. 8 and 0.12. Okay, 8. Oh, did I do this backwards? No, I did not. How do you spell Fairchild? F-A-R child. Imagine that. F-A-R Fairchild. Good night, Danny. Thanks for helping me. Alright, so this one has an 8 and a 0.12. Now, let's go find out what Stan used, shall we? They should be very similar. I'm going to turn this down. I'm probably gonna go to bed very soon. I'm very tired. I don't know if you can tell, but I'm very, very tired. Okay. So we're gonna go to the state photos. And look at, see if we can read the actual TIP120. Oh, I can see that's an LM304 motif. It's way over there. Might be able to read it on some of these, maybe somewhere. These are hard to see. Oh, I can see that one, and the light is no good. Now it has flash on it. Can't read it. I cannot read that. Cannot read that. You actually can't even see it on that one. It is isolated from the box though. This one's kind of blurry. That's a shame. Oh, you know what? That's the diode. Where's the TIP120? I'm looking at the wrong. TIP120 is mounted where? Now I'm confused. I thought it was on the back of the VIC card, like the aluminum piece. But now I'm second guessing myself. Unless it's underneath that transistor. I'm gonna look at the drawings. That's definitely the diode there. Not the TIP120. Where the heck is the TIP120? I'm very confused now. Oh, I am sleepy. Well, let's go look at his sketch real quick and see where it was mounted. 5-volt regulator. And both the TIP120s are mounted on VICs. Finish. Oh, you know what? I think I got the VIC wrapped, or not wrapped wrong, but wired up wrong, according to that drawing. That drawing is different. C2, L2. Oh. That's the start. Supposed to go to the diode. According to Don's sketch, it's different. Maybe I got it all backwards. Because let's look at C1. S goes there. The F goes to the diode. Goes to the F of the secondary. The S goes to that's right, so far the S. Oh, the S goes to the S. I've got that one switched. Guess we should fix that. That's according to a different diagram, so something to note. It might be wrong. according to this diagram, L2, the S goes to the S. So those are like bucking, so maybe those are backwards. Yep. Right. Huh. Well, okay. Interesting. Could have had those backwards the whole time. Happens. So I'm going to go ahead and use this other TIP120. I don't even know what this looks generic, but it's got a really, really thin tab on it. So the TIP120s are VIC coil pack. NC, no connected. 1-5 NC. So let's double check this. F, C2, S to S, F to S. Huh. That should have been pointed out. I should have known that better, but I was going off of a different diagram. We will switch it around. I want to go check the other diagram and make sure it's right. I may have just messed it up. Alright, live and learn. Okay. Now they're connected correctly. I pulled it out without turning the power off, didn't I? Oops. Alright, so I'm using the ST version. I'm going to go back and check this other picture now. Let's see. 2017. Okay, that drawing's right. S, that's wrong. This one's right, this one's wrong. This one, however, is correct. So okay, well I had that wrong the whole time, but that's okay. We fixed it. Alright, we know what the frequency is doing. I'm gonna go ahead and
Alright. So, now that we got that fixed, we got that figured out, let's just play around with this thing for like a half an hour and then I'm going to bed. Because I'm exhausted. I really still don't feel good. So I'm going to leave I guess I actually need all of the probes. Well, let's just connect the high voltage probes to the other part of this circuit before we go going crazy. So I got the blue. The blue is the base of the TIP120. The green is across the primary. Alright, and then I want to use I'm going to use the yellow as one side of the coil, or the capacitor. I want to use pink across the other side of that capacitor, just for the first test here. And then let's put the triggering on, yeah, that one. So, that's what it looks like. Now that we got our coils connected correctly, I sound better. Why? I feeling terrible. Okay. Alright. Okay, let's do this real fast. Let's do a frequency. Well, I don't want to do a frequency sweep, but I'm jumping. Big jumps here. Ooh. They're exactly inverted. No, this makes more sense. This is what we need to make the circuit work. I had those coils darn backwards the whole time. Alright, so we're going to go with a peak-to-peak frequency here. Let's go ahead and put a peak-to-peak value on that guy. I hope you can read those okay. The purple's a bit difficult to see on my... Yeah, you can
can see it fine.
Okay, and then the frequency of that channel, and we want the frequency of this channel. And then the very last one, let's just do across the, let's just go across the coil, why not? Okay. So voltage, voltage, frequency, frequency, and then we're just measuring across that. So I am going really fast. I'm just sweeping. Alright, so let's go way back down. 1 kilohertz ping test, okay? That is a mess. Let's go down to the like 100 hertz ping test. There's the 10 hertz ping test. Some weird stuff there, but okay. What I want to measure. Ooh, these are messy. Let's just measure the frequency the best we can here. Oh, you know what? We're not actually measuring across those coils. So this is a bad. We don't want to measure this. Let's just see what we get on resonance. We're climbing up to 1 kilohertz in 10 hertz increments. Is this the off or the on? This is the on time. Yeah, the off is that low peak. Okay. Alright, we're approaching. You can see it on the bottom, right? You can see that green really nicely. Yeah, you can see it frequency there really nicely. So there's 2 kilohertz. This is messy, isn't it? Oh, there's some nice amplitude though. It's around 3 kilohertz. Not too much voltage, but a little bit. There's 3.7, a little peak in there. Cells are dry, by the way, in case anyone's questioning. So look, we're half the frequency because you see the little double peak, and we're at 4.3. So we should be able to get resonance without going too high. So there's 5, and those are pretty balanced actually, but we're still not there. Get through that cycle. There's the yellow peaking, almost 6. The yellow is L1, capacitor side. I'm measuring just the leads going across the capacitor, by the way.
There's 7.5. Let's zoom in. It's nice that they're opposites now. That makes me feel better. Well, there's like nothing happening in this big bandwidth. It's pretty steady. I could probably go faster. But I'm just going to keep going slow. Scan the whole thing. Nice and easy, and see what we get. Okay, now we're coming up on something. Alright, there's the yellow. 12.2-ish. Now that coil is pretty well in resonance, or at least oscillating at a nice motion. Heard something pop, I don't know what it was. Maybe it's just me. Could be a lead or something. Alright, now we're hitting some nice resonance-ish. It's actually very low frequent voltage right now, but there's a sweet spot right there. 15.05. Still not as high voltage as what we were getting last time, but let's put our hand in here and see. Yeah. If I actually touch it, I don't feel anything. Maybe I can feel my teeth. It was doubling there. What if I go back down? It wasn't doubling. I'm gonna go a little bit faster. I'm gonna go in 100 hertz increments now. Oh, see right there. What is that like jump? Oh, maybe it's not. Oh, I gotta bring this one back up again. Like there, it's kind of doubling, right? Kinda, trying to. Let's go even bigger so we can really see what's happening there. You know, it's actually it's not. Yeah, it is doubling-ish. Another sweet spot, but this one's only at 10 volts. Well, there's your equal measurement. Oh, see, now it's interesting to me because this is actually like less interesting, right? I say that because if we scan through here, we can see we're scanning too big here, but so 15 point something. Now that's the capacitor. Okay, I'm gonna go to the bathroom and get a drink. Didn't see, and then I'm gonna measure across all of the coils simultaneously. So I'll be right back.
Okay. I'm very, very tired. So let's do this test fast. Going to bed. Okay. Now, alright. So now what I want to do is measure all coils equally, which means I'm going to be measuring across all of them. So green will still be primary, measured here now. Just a little bit different space. Alright, I'm going to measure so the start, no, the finish is always going to be ground, okay? So L1 is pink, purple, whatever it is. Start to the finish is always ground, okay? That way they're always measuring the same. Okay, and then the blue is the secondary. So Kevin, you still really interested in this project, huh? You seem like you're always here when I'm working on this lately. It's just fun. Okay, and then, so the blue is secondary, pink is L1, yellow is L2, and green is primary. And technically they're all connected, well, let's see, those are, let's finish the start. If I measure the start, with this probe it's measuring the same point, which is kind of useless. So how do we want to deal with that? I could measure no, this is a bit confusing because I'm actually measuring the exact same signal twice. Let's just see what it shows us really quickly. I'll do this. I'll measure all ground points in the same spot. So now we need to change. Trigger to channel 4. Okay. I'm gonna go in big chunks. I like how it grows. See how it growed? Let's change. Let's see. Well, we'll just leave it for the moment. I know, I'm jumping big jumps here. I need to really measure like the ground reference. That's 14.4. Green, blue, secondary. See, it's all confusing, but okay. Whatever, let's go fast, because I want to connect this a little bit differently. Okay, I'm either very, very tired or confused. I don't know which one. Maybe both. Because I guess technically to measure this the way I want to measure it, I need to ground reference all the same points instead of all the same parts. So I'm just going to stick all the grounds on this what you'd consider the ground on the VIC schematic. Okay? So that means blue is still on the secondary. Pink still on L2. And then yellow is on L2. So all the grounds are referencing the same place except for basically the primary. It's on its own. But I could connect it over here if I really wanted to. Okay. I think we're alright. So now we're measuring. Kind of want to see what's going on the other side of that diode. I can always move this pink one. So the pink and the blue. Let me do that actually. I'm just measuring across the diode. So the difference between the pink and the blue trace. And I just want to do a quick sweep. I'm kind of curious if they're always like they're a little different, yeah. Kind of messy. See, like there at resonance ish, we're about 15 kilohertz again. Everything's kind of in phase, you know. Now if I put this on L2, it's out of, or on the S output of L2, going to the capacitor. So this one. There, they're all on the same scale now. I mean, this seems like the best, maybe not the best, but the most happiest spot. Yeah, that's that voltage. Okay, I want to change the voltage a little bit for fun. Oops. So the lower the voltage, you know, it changes everything. So the frequency went up, as in if I turned the voltage up, I had to bring the frequency up. But my voltages are still quite low. You can totally see how that affects it though. Okay. Well, with this TIP 120, I can go up to 30 kilohertz. So it all depends on the tip. And I can't find, see if you can find which tip is in the state photos. I can't seem to find it anywhere. Can't actually see that. Okay. Well, I don't know what I learned, but I know I'm tired. So I'm going to bed. See you guys another day.